Hi, so in this video we're going to be going over the AP Calculus BC 2008 FRQ question number 4. Here's a look at it right now. This is what it is. If you'd like to solve it on your own before we go through this video, feel free to pause right now. If not, we're going to launch right into this and go over some of the solutions. So a particle moves along the x-axis so that its velocity at time t for the time in between 0 and 6 is given by a differentiable function v, whose graph is shown above. The velocity is 0 at t equals 0, t equals 3, and t equals 5, and the graph has horizontal tangents at t equals 1 and t equals 4. The areas of the regions bounded by the t-axis in the graph of v on the intervals of 0 to 3, 3 to 5, and 5 to 6 are 8, 3, and 2 respectively. At time t equals 0, the particle is at x equals -2. So for part A, what we're doing is on the interval of 0 to 6, find both the time and position of the particle when the particle is furthest to the left. Justify your answer. So what we want to be doing here is basically just finding where we have the largest negative value, because the largest negative value of x of t is where it's going to be furthest to the left. So what we see here, we have these values that are highlighted, right? On the interval of 0 to 3, 3 to 5, and 5 to 6, we have different areas. We have 8, 3, and 2. And so from here, looking at this graph, we can see that this 8 from 0 to 3, the area in here is going to be 8, and that distance is going to be a negative. So we have a -8 here. And then this distance right here, 3 to 5, is going to be a +3 because it's above the x-axis, or the t-axis. And on this side, from 5 to 6, we'll have a -2 because it is below the t-axis. And so basically, because what we're looking at here is the area under these curves, the area of this right here is going to be the distance traveled by the particle. So on the interval 0 to 3, the particle has traveled -8, so 8 to the left. And then from 3 to 5, it's traveled 3 to the right. And then from 5 to 6, it's traveled 2 to the left. And so what we have to do here is we're recognizing that this area underneath the curve is the distance traveled, which is the same as saying we have the integral of v of t dt. And so what we're trying to do here is just, like we said, find the most left point. And the furthest left, like we said, is the most negative. And so what we can do is plug in some of these different values. We have an initial condition of at t of 0, x equals -2. So we will factor that into everything. We'll have -2 minus 8 equals -10 if we're looking at the integral of v of t from 3 to 0. And if we're looking at it from 6 to 0, we have -2 minus 8 plus 3 minus 2, and that equals -9. And so what we see here is that at t equals 3, we have our most negative point. And so that means that x of 3 is going to be where that is, and the value of x of 3 is -10. So if we look at the actual scoring guide for that, we'll see here, since v of t is less than 0 on the interval of 0 to 3 and 5 to 6, and v of t is positive for 3 to 5, we consider 3 and 6, right, these two values, because that's where it's going to be getting smaller. And then we have x of 3 is basically exactly what we just did. They're using an integral. We used -8, which is the value of that integral, so that ends up being the exact same thing, -10. Then x of 6 ends up being -9. And so we see the particle is furthest left at time equals 3 when the position x of 3 equals -10. And so here it's important to consider these different times and areas as candidates, otherwise we don't get these points. So t equals 3, that is based off of what we have up top. The integral to 0 v of t, that's one you might not think to do just because we don't have like the most negative value at that point, but we do have to consider it and eliminate it. we can't just assume that it's at t equals 3, and then we have a conclusion based off of that information. So for part B, we have how many values of t on that 0 to 6. The particle is at x equals -8. And so this one, the best way to do it in my eyes is to make a number line. We have x of t, and we are going to find the points at these values, these critical points, and we're going to see what values they have. So our critical points are going to be at 0, 3, 5, and 6, right? Because that's where our velocity is equal to 0. So that means what we have that is we're looking at these values and we see that at x of 0 we have -2, and then at x of 3 we have -10, and then we have -7 at x of 5, and at x of 6 we have -9. So that means that we're looking for places where -8 is in between these two numbers, and -8 is in between -2 and -10. It's in between -10 and -7, and it's in between -7 and -9. So that means there's 3 different places where x equals -8. And if we look at our scoring guide, we see the same thing. They're saying exactly what we just said, and by the intermediate value theorem, this is how we get that. So for the next part of the problem, we have on the interval 2 to 3, is the speed of the particle increasing or decreasing? Give a reason for your answer. Now, this one, all we have to do is look at, well, first we have to recognize that speed is the absolute value of velocity. So it doesn't have a direction or a positive or negative behind it. So we're just looking at, is the value getting further away from 0, or is it getting closer to 0? If it's getting further away from 0, then we're speeding up. If it's getting closer to 0, we're slowing down. And so what we're doing is we're looking at v of t, right? And we see on this graph that on the interval of 2 to 3, that it's getting closer to 0. So that means that our speed is going to be decreasing because v of t is getting closer to 0. If we look at the scoring guide, we'll see that same thing, exactly what we just said. So for part D, during what time intervals, if any, is the acceleration of the particle negative? Justify your answer. So what we're going to look for here is the derivative of t, because the derivative of v of t, because the derivative of v of t is going to be our acceleration of t, and acceleration, based on whether it's positive or negative, we'll be able to see if the speed is decreasing or increasing. What we're going to look at here is see that we have a number line of v prime of t. Using our information provided up here at the beginning of the problem, we'll see that the graph has horizontal tangents at t equals 1 and t equals 4. That means that v prime of t equals 0 at 1 and 4. And if we just look at this graph, we can see what we're looking for here, v prime of t, is going to be the slope of v of t. And so we see after this critical point, we're going to have a positive. After this critical point right here, we're going to have a negative. And on the other side over here, we'll have a negative as well. And so if we draw that out into a nice little number line, like we have right here, we have negative from 0 to 1, positive from 1 to 4, and negative from 4 to 6. And so from that, we can see that the acceleration is negative on 0 to 1 and 4 to 6, since v prime of t is negative on those intervals. And if we look at the key, we see the exact same thing. The acceleration is negative on the intervals 0 to 1 and 4 to 6, since the velocity is decreasing on those intervals. That's all there is to this problem. It's pretty straightforward once you understand what's actually happening. It is a little bit weird though, how they don't give you an actual function and they just give you these values. It actually makes it easier though if you're able to put it all together and make it work. There will be a link that you'll be able to click on in the description box below if you want to go and see more problems like this. So if you feel like you can master this with more practice, then that's a great option. Thank you for watching.